So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 328, and in this video we continue again with our exercise, and we stopped here on the number 32. And like all time, you read here the question, pause the video, try to answer as good as you can, and then compare it with my answer, or better with a good C++ book, online resources, or what you have. Alright, let's get started. So here the question: any expression that designates a temporary object after temporary materialization. So what is that? First of all, you should try to figure out the value category and make a code example. And like all time, I will not pause the video, I just jump to the answer, but you should pause and try it first. So let's jump to the answer. Let's go here first. So the value category is an X value. So we should make there an X value, and let's go to the code section for a code example. I have here a code example from ChatGPT, so it's not a perfect code, but for demonstration purposes, okay. But you can see bad style like all time, no comments, and yeah, so on. But that's not very important right now. Let's go and read this code example. First of all, we have here a class, and we have here publics and private, and we have a constructor destructor, and the constructor has a body where we put out the value, which is just an integer value, which is private, and we have a destructor which has a body as well, so that we can see when the constructor and destructor is called, and we print all time the value here, and the value is private. That's why we have here one more function, and this function is getter, but it is called here get value. But I hope you know what a getter and setter is. It means that you can get values which are private from an object, and we need this if we want to use that outside of this class here. I hope so far it's pretty easy and forward. But then we have here a function, and this function has parameters, one parameter, and this parameter is very well known by now, I hope, because you can see it's a const, and then we have an object reference and identifier. And this construct we used all time before for what? For the word const was used so that we can't reverse change values of the reference, right? When we have a reference and there is not a word const, we could just access this object here. So let's say object get value, and I could change theoretically the value here. But with const, we guarantee we won't not change it. We won't just get a reference, and we avoid a copy. That what we learned before, right? But very important, with the value categories, we learned a second meaning. The word const was used there to extend the lifetime when a PR value is bound to this const here, right? So, and here we will make soon an example, but before we go there, let's read here a little bit more so you can see the function here has also an output. And here we will just take this created object here, and we get the value, and you can see it is my class here, which I explained to you before, that my class 2. And yeah, now we can jump to the function call. So here in main, and interesting is here I call this function, but look what I call it. My argument so is 42. 42 is a PR value, we know that. It is a temporary value, and the problem here is when you watch this one and this one, wait a minute, this function here expects a const my class 2 reference, and we don't have it here. And that is the new thing what we are learning with temporary materialization. It is one example, but there are many other places where temporary materialization occurs as well. And how this works. First of all, let's see what the compiler does here. First of all, the compiler is here, it reads this function and says, okay, you have an argument 42. I jump to the print value function. It tries to find any. It finds only this one here because I have only provided this one. Then the compiler says, oh, we have here a const and a PR value. I can bind to const. That is very nice. But we have here an object reference. This works as well only if this object reference here has a constructor. Yes, it has a constructor which can take a value. So you can see we have here one parameter, and this parameter will now be placed for the class here in the constructor. So the compiler is doing what? The compiler creates here a temporary object of my class 2. Then it takes this argument 42. Instead of passing it here, it passes in the constructor parameter here. And the constructor is assigning it to the value here in private. That's the normal constructor thing. But the important thing you note is the compiler is creating here a temporary object, and this temporary object is created with this PR value. Why I say a temporary object? Because normally when you call this function, you expect that my class variable, for example, is before created already, and then you pass it here. So because we make here a reference, and we learned with reference, normally you should have already an object. That was what we learned with references, right? But in this case, this is a special case. The compiler create this temporary object, and that works only with const. Without const here, that will not work. This temporary object will be not created, and this value 42 will not bind to this one. This is the first step, but there is a second step. The second step is, okay, now we created this temporary object. The compiler goes to the body, and it can access now this temporary object, just normal, right? It gets here, get the value to the getter, and it prints out the value, which is 42. So far, so nice. Then this after this one, we are not finished, because after the compiler finished this instruction here, right, the compiler goes back to this object and destroys it, because it was just a temporary object. It was just created here, it was used here, and after that, between this body here, after it ends, the compiler says, okay, this was temporarily created, it has its use case within this body here, this brackets in this scope, and after this scope I destroy it. And that means that the compiler jumps again to my class temporary object, finds the destructor, and the destructor will call this body here, destructor called with the value again. And when I start here this program, you can see in the first 3 lines here exactly that happens. So here, fast recap. So we have here this call here with print value 42. Then the compiler jumps to our function. It finds here just this class reference for this one. But this is a special case because we know a PR value can bind to a const. Very important. This const has here a different meaning with value categories. It can bind to a temporary object, and this value 42 will be used in the constructor, and you can see it here in the first line. Constructor called for 42, that is this one. The temporary object was here created, and then it uses this temporary object on line 2. You can see value 42, this is the line 2, that was this line here, where we use it in the body, and after the scope, which is the curly braces, end of the curly braces, the compiler jumps again to this temporary object which was here created, and goes here to the destructor and calls it, and you can see it here in the line 3. So, and this is called, it is only one example of temporary materialization, but there are many different places as well. And this kind of stuff you should read a little bit online in good C++ book, because that would to be much when we do all things here, but this was just one example. So I hope you understand this concept, because this will be used, I think, if it's possible, many will use it. Why they won't use this kind of stuff? The reason is very simple. If you can create a temporary object, use it where you need it, and then destroy it, this will save resources. For example, if I have here many classes and I create them and create them and create them, this will waste resources. But with this concept here, just create it, use it, and after you don't need it anymore, destroy it. So this kind of stuff you will see a lot, if it's possible, of course. So, and with that said, I hope you understand this one here as well. And if you have any questions, like all time, write in the comment section. See you in the next video. Bye, good luck, and like all time, have fun.